Hello students and good afternoon. So now today we are doing composition of functions. So in the last online class we did problems on functions. So today we'll do composition of functions. So what is meant by composition of functions now? Okay. So now in this case you have to take the two given functions. One is f such that one function is f such that a to b, and the another function is g such that b to c, right? Suppose this is one set, this is another set b, and this is another set c, right? So this is your a, this is your b, and this is your c. Is that clear? Now in this case, this is the function f and this is the function g, right? So here f such that function f such that from a to b, the function g such that from b to c. So from a to c, how will you write it? Directly from a to c you have to write GOF, GOF. GOF, GOF. GOF means GOF, GOF such that it is from A to C, right? And this GOF is defined as GOF of x is defined as is equal to G of within second bracket or within first bracket you can write f of x. That is GOF of x is defined as G of f of x. Is that clear? So this is known as the composition of the functions of f as well as g. Is that clear to all of you? From a to c you have to write GOF, not fog. It's not fog, but it is GOF. Okay, and the domain of GOF is equal to domain of the function f. Is that clear? So next, now let us write down the definition of composition of functions. So I think you have understood this. Composition of functions. This is the pictorial diagram of composition of functions. Okay, so now let's define this composition of functions. Okay, so now let us define composition of functions. So let f such that a to b and g such that b to c be two given functions, be two given functions, be two given functions. Then the composition of the two functions, then the composition of two functions, then the composition of two functions, then the composition of two functions f and g denoted by GOF, right? Denoted by GOF is the function defined by let f such that a to b and g such that b to c be two given functions. Okay, then the composition of two functions f and g denoted by GOF, GOF, not fog. GOF is the function defined by GOF such that from a to c, such that what do we write? GOF of x, which is defined as g of f of x. So GOF of x is defined as G of f of x for all x belongs to the set A. Is that clear? So this is the definition of the composition of functions. That is, let f such that a to b and g such that b to c be two given functions. Then the composition of two functions f and g denoted by GOF but not FOG is the function defined by GOF such that from a to direct c, such that, or is defined as GOF of x is equal to G of f of x for all x belongs to the set A. Is that clear? So now in this case you have to remember that the domain of GOF, so domain of GOF is equal to domain of f. What is the domain of GOF? It is the domain of f. Okay, is equal to domain of f. Is that clear now? For FOG, for FOG, if you write FOG, for FOG, if you write FOG, then domain of FOG is equal to, if it is FOG FOG, then domain of FOG is equal to domain of Z, is equal to domain of Z. So you have to remember these two conditions also. That is, domain of GOF is equal to domain of F. For this is for GOF, and for FOG, domain of FOG is equal to domain of Z. So I think you have understood it. So you note that pictorial diagram also. Before we did this definition, we have drawn that pictorial diagram of GOF. So you have to copy that one also, and you also copy this definition. Okay, so now we'll do some problems on this composition of functions. So I think you have understood it. You can note it down. So now we'll do some problems. So now we will do problems from exercise 2B. This is page number RF38. RF means relation and function. From relation and function chapter, that is page number 38. From the book Senior Secondary School Mathematics for class 12 by R.S. Agarwal. Okay. So let's do this question number 1. So here it is given that let set A is equal to 1, 2, 3, 4. And let f such that, f is the function from a to a, and g such that, and the function g is there, g such that from a to a. Okay, it is defined as, function f is defined as f is equal to, within second bracket there is ordered pair given, that is 1 is related with 4, 2 is related with 1, 3 is related with 3, and 4 is related with 2. Okay, this is the function f. And the function g is defined as, within second bracket 1, 3, that is 1 is related with 3, 2 is related with 1, 3 is related with 2, and 4 is related with 4. Now we have to find out number 1 GOF, G-O-F, number 2 FOG, F-O-G, and number 3 FOF, F-O-F. Is that clear? So now let us find out GOF first. So number 1, okay. So in order to find out GOF, you have to find out GOF of x first, which is equal to, now in this case GOF of x, this x is the domain of, it is the domain of f, that is domain of GOF is equal to domain of f. So what is the domain of f here? 1, 2, 3, 4. This first number of f denotes the domain of f, and the second number denotes the range of f. Okay, now let us find out first GOF of 1. Okay, GOF of, instead of x you should put the domain of f, that is 1. Okay, so which is equal to, this is defined as z of f of 1. So what is f of 1 now? 1 is related with 4, that is f of 1 is 4 in this case, which is equal to g of 4. And what is 4 under g? That is, अब g मा हेर्नु तिमीले, Z of 4 means 4 is related with what? 4. In this case, under Z, 4 is related with 4. So its value is 4 here. Is that clear? So similarly, you can find out GOF instead of X. What will you put now? Instead of X, what will you put now? Now you should put 2. This is 2, which is equal to Z of F of 2, which is equal to, what is F of 2 now here in this case? F of 2 means 2 is related with 1 under F, that is Z of 1. So now in this case, under Z, 1 is related with what? 1 is related with 3 under Z. So it is 3. 1 is related with 3 under Z function. That is Z of 1 is 3 in this case. So I think you have understood it. Again, what is GOF of 3? Now GOF of 3 is there, isn't it? Now you should write, instead of X, you put 3 here, which is equal to, it is defined as Z of F of 3, which is equal to Z of, what is F of 3 now? Now 3 is related with 3 under F. So its value is 3. Next, what is Z of 3? 3 is related with 2 under Z. 3 is related to 2 under Z. Okay. So what is Z of 3 now? It is 2. Is that clear? So similarly, GOF of what? 4. So it is GOF of 4 is equal to, it is defined as Z of F of 4. Okay. So which is equal to Z of, within bracket, F of 4 means to which element is this 4 related under F. Okay. To which element does this 4 relate? To which element does this 4 relate under F? So 4 is related with, 4 relates with 2 under F, isn't it? So F of 4 is 2 in this case. Z of 2, which is equal to, now 2 is related with, that is 2 is related with 1 under Z, isn't it? What is Z of 2? Z of 2 means to which element does this 2 relate under Z? So this 2 relates with 1 under Z. So its value is 1. So I think you have understood it. So now you can write down the answer for GOF. So actually, what is the answer for GOF? How will you write down the answer for GOF of X or only GOF? Okay. So therefore, GOF is equal to, within second bracket, you have to write it in terms of ordered pair, isn't it? So GOF is equal to, this is 1 comma 4. So within bracket, it is 1 comma 4. This is the first element of GOF. Next 2 comma 3. Next is 2 comma 3. Next, you have to write it in terms of order pair. Is that clear? So next one is 3 comma 2. Next one is 3 comma 2. What is the next one? It is 4 comma 1. Here you can write 4 comma 1. Second bracket is closed. So I think you have understood it. So this is the answer. This is the answer for GOF. Is that clear to all of you? So I think you have understood it. So you can copy it. Now we'll do this number 2 and then number 3. Okay. So you have to understand it, right? So I think you have understood it. So you can copy it. Now we'll do the next question. That is question number 2. So now, similarly, you can do this question number 2. You can find out fog, right? So let us find out fog. So in order to find out fog, you have to find out fog of this one. G is there, isn't it? That is, domain of fog will be equal to domain of Z. Domain of fog is equal to domain of Z. In this case, domain of GOF was domain of Z. Domain of GOF was domain of F. Domain of GOF is equal to domain of F in this case. And for this fog, domain of fog is equal to domain of Z. Is that clear? So let us find out first. In order to find out fog, you have to find out fog of this one, fog of 2, fog of 3, fog of 4, right? So let us find out this fog of this domain of fog is equal to domain of Z. Z but start garnu paryo aba. So now fog of 1 is equal to, it is defined as what? It is defined as f of Z of 1, which is equal to f of, now this one is related with which number? This one is related with which number? 3 under Z. That means what is Z of 1? It is 3. Is that clear? So this is f of 3. Now how will you get the value for f of 3? Now this 3 is related with which number under f? This 3 is related with 3 under f. Okay, so what is the value for f of 3? It is 3. So I think you have understood it. Okay, next you have to find out FOZ fog, that is domain of Z 2. Now it is 2. So which is defined as, this is f of Z of 2, which is equal to f of, now what is the value for G of 2? This means that 2 is related with which number under Z? That is 2 is related with 1 under Z. That means what is the value for G of 2? It is 1. Is that clear now? Next, what is the value for f of 1? Now 1 is related with which number under f? 1 is related with 4 under f. So which is equal to, this one is 4. So I think you have understood this is fog of 2. Next you have to find out fog of 3. So how is it defined as fog of 3? It is defined as f of Z of 3. Is that clear? Next, f, keep it as it is within bracket. Z of 3 means 3 is related with which number under Z? So under Z, 3 is related with 2 under Z. So it is 2. Now what is the value for f of 2? Now what is the value for f of 2? Your 2 say kun चाहिँ number सँग relation छ under f? Under f, this 2 is related with 1 under f, isn't it? So it is 1. So I think you have understood it. Next, FOZ fog of what? Number 4. So what is fog of 4 is equal to? It is defined as f of Z of 4 is equal to f of within bracket. So what is the value for G of 4? This indicates that 4 is related with which number under Z? Under Z, this 4 is related with 4. Now f of 4 means, what is the value for f of 4? That is 4 is related with which number under f? That is 4 is related with 2. So its value is 2. So I think you have understood it. So now you can find out the function, that is you can find out the value of fog, right? So therefore FOZ fog is equal to, so now you have to write down all these numbers in ordered pair, right? So FOZ fog is equal to 1 comma 3 is 1 is 3, isn't it? 1 comma 3, that is 1 is related with 3 comma next 2 is related with 4, right? 2 is related with 4. Next, this 3 is related with 1. This 3 is related with 1. Next, this 4 is related with 2. This 4 is related with 2. So this is the final answer. So this is the value of fog. So this is your final answer. So I think you have understood it. You can copy it. Now we'll do the next problem, that is number 3. So now we will find out, this is number 3, FOF, F-O-F, FOF, right? So number 3 is FOF. That means you have to find out FOF, that is FOF. Domain of FOF is domain of F. itself. Okay, so domain of f is 1 2 3 4, right? So you first find out f of f1. You first find out f of 1, which is defined as f of 1 is equal to f of, now within bracket f of 1 is there. This means that 1 is related with which number under f? 1 is related with 4, right? So 1 is related with 4 under f. That is, what is the value for f of 1? It is 4, which is equal to, again, f of 4 means, what is the value for f of 4? That means 4 is related with which number under f? 4 is related with 2 under f. That is, it is 2. So I think you have understood it. Okay. Next, f of what? 2. So which is equal to, it is defined as f of 2, which is equal to f of, within bracket, now there is f of 2. What is meant by f of 2? 2 is related with which number under f? That is, 2 is related with 1 under f. So its value is 1, which is equal to, now what is the value for f of 1? So this 1 is related with which number under f? That is, 1 is related with 4 under f. So f of 1 is 4 in this case. Okay. So next, f of f within bracket 3 is there. So it is defined as f of 3. You write f first, then f of 3 means, 3 is related with which number under f? 3 is related with 3 under f. That is 3, which is equal to, again, this 3 is related with 3 under f. That is, which is equal to 3. Next, you have to find out f of 4, which is equal to, it is defined as f of 4, which is equal to this f. This f is kept as it is. So how can you get the value for f of 4? That means 4 is related with which number under f? That means 4 is related with which number under f? That is, 4 is related with 2. That is f of 2, which is equal to, what is the value for f of 2 now? 2 is related with which number under f? 2 is related with 1 under f. So its value is 1. Okay. So now you have to write down f in terms of ordered pair, right? So you have to write down this function f as is equal to, you have to write it in terms of order pair. That is this 1 comma 2, this is 1 comma 2, right? Next 2 comma 4, next 3 is related with 3 under f, right? And this 4 is related with 1 under f, right? So this is 4 comma 1. So this is the final answer. So this is your f. So I think you have understood it. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. It is given that let the function f such that r to r, that is real number to real number, and this function f is defined as f of x is equal to x square, and there is another function g such that r to r, that is also real to real number, and is defined as g of x is equal to x plus 1. This is second function, that is g of x is equal to x plus 1. You have to prove that gof not equal to fog. Gof not equal to fog. Okay. So now let us find out this left hand side, gof. Left hand side is gof and is defined as GOF of x, right? Which is equal to, again it is defined as g of f of x. Is that clear? Is equal to, now in this case how will you simplify it? You put the value for f of x given in the question. What is f of x? It is your x square. So this is z of x square. So instead of x, there is x square now. So we have put the value for f of x, which is equal to x square. So this is z of x square. So in case of x, it is x square here. So now we have to find out g of x. What is g of x there? It is x plus 1. So instead of x, there is x square plus 1. So if g of x is equal to x plus 1, so what is g of x square? It is, instead of x, you put x square on the right hand side. That is your x square plus 1. So I think you have understood it. This is your left hand side. Okay. Now let us find out right hand side now. So RHS, what is RHS here? It is fog. It is given as fog, FOG, right? So actually you have to find out FOG, fog of x, right? Now it is defined as f of z of x. It is defined as f of z of x, right? Now instead of g of x, you put the value for g of x. What is that? X plus 1, right? So f of x plus 1. Now this is in the form f of x, and instead of x there is x plus 1. But you know that what is f of x is equal to, this is x square, but instead of x it is x plus 1. So instead of x, if you put x plus 1 on the right hand side, this will be x plus 1 whole square, isn't it? So you have to write x plus 1 whole square, which is equal to, so what is x plus 1 whole square? This is x square plus 2x plus 1. You know that this is your a plus b whole square. So which is equal to x square plus 2x plus 1. So I think you have understood it. So are they equal? Are these two functions equal? No. That means GOF not equal to fog. So therefore you have to write GOF not equal to fog. So this is proved. So I think you have understood it. Okay, you can copy it. Now we'll do the next question now. So now let's do this question number 5. The question is, let the function f such that r to r, that means real to real number, is defined as f of x is equal to x square plus 3x plus 1, and there is a function g such that r to r, that is also real to real number, and is defined as g of x is equal to 2x minus 3. So it is given. These two functions are given. One is f of x and the other one is g of x. Okay, so you have to write down the formula for number 1, GOF, that means you have to find out GOF of x. Number 2, you have to find out fog, that means fog of x. And number 3, GOG, that is GOG of x. Okay, now let us find out GOF first. So number 1, in order to find out GOF, you have to find out GOF of x. You have to find out what? GOF of x. So it is defined as what? Z of f of x, right? So now how do you simplify it? Now within bracket there is f of x. Put the value for f of x. What is f of x here? It is x square plus 3x plus 1. So it is z of, within bracket, what is f of x? X square plus 3x plus 1. Now instead of x there is x square plus 3x plus 1. This is g of x, right? So actually what is given in the question for g of x, which is equal to 2x minus 3. So now instead of x you have to put x square plus 3x plus 1, right? So which is equal to, its value is 2 into, now on the right hand side there is x, and instead of x you put x square plus 3x plus 1, that is x square plus 3x plus 1, bracket closed. Then write down this is minus 3. So I think you have understood it. So multiply it, which is equal to 2x square plus 6x plus 2 minus 3, right? So which is equal to 2x square plus 6x plus 2 minus 3 is, this is minus 1. So this is the answer for the first question, that is GOF of x or GOF, right? So now next, so I think you have understood it. So we have found out GOF, that is GOF of x, which is equal to 2x squared plus 6x minus 1. So I think you have understood it, okay? So next, let's do fog. Let us find out for fog. That means you have to find out fog of x, right? So fog of x. So similarly, you can simplify it. So fog of x is defined as f of g of x. Okay. So next, which is equal to f of, now you can put the value of g of x. What is that g of x? It is 2x minus 3. Put its value. It is 2x minus 3. Now instead of x, there is 2x minus 3. So f of x is there. So instead of x, there is 2x minus 3. So actually, what is f of x? It is x squared plus 3x plus 1. Now instead of x, what should we put? We should put 2x minus 3. Okay. What is x whole square? This is 2x minus 3 whole square, right? Plus 3 into, again, what is the value for x in this case? It is 2x minus 3. Is that clear? So write down 2x minus 3 here, and then plus 1 is constant. Plus 1. Okay. Now let us simplify it. You know that this is a minus b whole square. You know the formula, a square minus 2ab plus b whole square, right? So what is 2x whole square? It is 4x square minus, what is twice ab? 2 into 2x into 3. That is your 12x. Then plus 9. Is that clear? अब त्यसपछि हामी फेरि 3 ले मल्टिप्लाई गर्छौं. Plus 3 2s are 6x minus 3 3s are 9. Then it is plus 1. Okay. So now you can simplify it further. Here 9 and gets cancels, which is equal to, this is your 4x square. Okay. Minus 12x plus 6x. You can subtract it. This is minus 6x. Okay. Then you have to write plus 1. So this is the answer for the second part. So I think you have understood this one also. Okay. Now let's find out number 3 now. GOG. That is number 3. In order to find out GOG, you have to find out GOG of x. So it is GOG of x is equal to, now it is defined as g of x, which is equal to, now put the value for g of x for the expression within bracket. There is g of x. So this g is kept as it is. What is g of x? It is 2x minus 3. This is your 2x minus 3, which is equal to, now instead of x there is x, g of x. Actually, what is g of x? 2x minus 3. So instead of that x on the right hand side, you should put 2x minus 3 again, right? So 2 into, what is x again? It is 2x minus 3. It is 2x minus 3, then minus 3. Is that clear? G of x is there, but we have to get the value for g of 2x minus 3. So instead of x, there is 2x minus 3. So on the right hand side also, you put x is equal to 2x minus 3. So it becomes 2 into 2x minus 3. Then minus 3 is constant. So it is kept as it is. Okay. Now let us simplify it. It is 4x, then minus 6, minus 3, which is equal to, this is your 4x minus 9. This is the value of GOG. So 4x minus 3. Sorry, this is 4x minus 6 minus 3 is 4x minus 9. That is the value for GOG of x. So I think you have understood it. So you can copy it. You can note it down. Now we'll do the next question now. So now let's do this question number 8. The question number 8 is, let the function f such that r to r, that is also real to real number, defined as f of x is equal to 2x minus 3, that is f of x is equal to x minus 3, and the function g such that r to r, that is also real to real number, defined by g of x is equal to half within bracket x plus 3. Okay, this is given functions, right? You have to show that fog is equal to IR. IR means identity function. IR means identity function is equal to GOF. That is, GOF is also identity function, fog is also identity function. You have to prove it. Okay. Now, first of all, let us find out fog. So, therefore, that is A for Z of X. That is, let us find out A for Z of fog of X. It is defined as A of Z of X, which is equal to, now instead of G of X, put the value for G of X from there. It is half X plus 3. So this is A of within bracket half. This is your X plus 3. So now here instead of X there is half into X plus 3. But what is the value for F of X? It is 2X minus 3. So now instead of X you have to put half into X plus 3 now. So which is equal to, now here it is 2 into, what is X here? It is whole term, that is half into X plus 3, and then you write minus 3. So here 2 gets cancels, which is equal to, now this one is X plus 3 minus 3. 3 gets cancels, which is equal to X. That means it is an identity function, right? So which is equal to this is IRX. That is, this is your identity function. So this X can be written as IR within bracket X. You know identity function, isn't it? This function, identity function, says that A to A is known as identity function if IA of X is equal to X. I told you this one about identity function while doing the function, isn't it? While doing the definition of function, I told you about the identity function also. That is, if the function IA such that A to A is there, so what is IA of X, which is equal to X? This is known as identity function. Okay. So next, you have to find out GOF. You have to find out GOF now. So from here you can write down that, from these two you can write down that fog is equal to IR. Okay, that is identity function. Therefore, A for Z fog is equal to IR. यो X हामीले नलेख्दा पनि हुन्छ. बुझ्यो? यो X हामीले नलेख्दा पनि हुन्छ. That means you can write A for Z fog is equal to this IR. So similarly you can prove GOF is equal to IR. So let us find out first GOF of X. GOF of X is equal to, now it is defined as Z of F of X. Z of F of X, which is equal to, so instead of F of X, what should we put? You F of X go 2X minus 3, you know that, isn't it? So Z of, this is your 2X minus 3. Is that clear? Now, instead of X, there is 2X minus 3. But what is Z of X? Z of X is equal to half into X plus 3. So, which is equal to, now wherever there is X, so wherever there is X, you have to put 2X minus 3. Okay? So, it is half within bracket. Now, X is within bracket. So, instead of X, you write this 2X minus 3, then write down plus 3. So, I think you have understood it. Since G of X is equal to half into X plus 3, so जहाँ X हामी के हाल्छौं 2X minus 3. So G of 2X minus 3 is equal to half within bracket. Instead of X, you put 2X minus 3, then plus 3. You will get this expression, isn't it? So here 3 gets cancels, which is equal to half into 2X. Again 2 gets cancels, which is equal to X, which is equal to, it can be written as IR of X. So I think you have understood it. Okay. So now this GOF of X is equal to IR of X. IR of X, that is your identity function. So अब यो X हामीले नलेख्दा पनि हुन्छ. That is your GOF is equal to IR. So I think you have understood it. Hence we have proved that. Hence FOZ fog is equal to IR is equal to GOF. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 9. Let the function f such that z to z. What is z here? Z is the set of integers. It may be positive integers, it may be negative integers, including 0 also. Okay? Define as f of x equal to x. You have to find out g function. G such that z to z, that is integer to integer, and is defined as gof is equal to identity function. Gof is equal to iz means identity function on the set of integers. Okay, so now it is given that here given is so let us assume that let x belongs to the set of integers. Okay, now it is given that gof is equal to iz. Okay, now let us write here gof of x. Gof of x is equal to iz of x. Gof of x is equal to iz of x. Okay, now it is defined as z of f of x. G of f of x is equal to x. Iz of x means x. This is your identity function, isn't it? So now what is f of x here? It is 2x. So it is z of 2x is equal to x. Is that clear to all of you? Now we have to find out g of y or g of x only. You have to find out g of x only or g of y. Let us assume let y is equal to 2x. So what is the value for x in this case? This is x is equal to y by 2. So here you can put, therefore z of y is equal to, what is x here? This is your y by 2. So now here in this case you can write, instead of y you may write x also, that is z of x is equal to x by 2. So this is the final answer. So I think you have understood it. Gof is equal to iz is given, write on gof of x is equal to iz of x. Okay, so this is defined as g of f of x is equal to iz of x means x. So f of x is 2x out here, you put g of 2x is equal to x. Okay, so let y is equal to 2x. Let us assume y is equal to x, because you have to get the value of g of x only. So don't put 2x is equal to x here, because it will be complicated. You will get confused if you write 2x is equal to x. So you put 2x is equal to y in this case. Okay, so if you put y is equal to 2x, so x is equal to y by 2. So g of 2x means it is y, g of y is equal to, what is x here? It is y by 2. So now you can replace y by x. So what is g of x is equal to? This is x by 2. So this is the final answer. So I think you have understood it. So you can copy it. This question is important question. Okay, so now we'll do the next question now. So now we'll do the next question, that is question number 6. So question number 6 is let the function f such that real to real number r to r is defined as f of x is equal to, this is your modulus function, f of x is equal to within mod x. You have to prove that f of f is equal to f. That means you have to find out f of x, isn't it? So therefore f of x, which is defined as f of x, which is equal to, next you have to put the value for f of x. What is f of x? Within mod x, f of, that is within mod, it is x, which is equal to, so instead of x there is within mod x, instead of x there is within mod x. What is the value for f of within mod x? Again you have to put it within mod x. You have to put this mod x within mod again, because you have f of x is equal to within mod x is there, isn't it? So here again instead of x there is within mod x. So you have to write f of within mod x is equal to within mod, again within mod x. Is that clear? So which is equivalent to within mod x, isn't it? So if you put x is equal to -1, if you put x is equal to -1, this will be within mod -1, which is equal to within mod, this within mod -1 means 1, which is equal to 1. Is that clear? So this one can be written within mod 1. So it is the same thing, right? So within mod x means within mod it is x. Within mod there is again within mod there is mod x, right? Within mod there is mod x, which is equivalent to mod x. Is it clear to all of you? So I think you have understood it. Okay, so that is within mod there is mod -1, which is equal to mod 1, which is equal to 1, isn't it? So you don't have to write down both this mode here. So single mode, you can write single mode there. So which is equal to within mod x. Okay, so within mod x, what is within mod x? Actually it is f of x, which is equal to f of x. So which implies that f of x is equal to f of x, which implies that f of f is equal to f. Proved. So is that understood now? So एउटा तिमीले के याद गर्नुपर्छ भन्दाखेरि यदि within mod there is another mod within mod x -1, this is equivalent to only one mod. Okay, if within mod there is another mod x -1, you have to write only one mod, that is within mod x -1. So both will give you the same value. Suppose if you put x is equal to -1 here, if you put x is equal to -1, it will be -1 -1, right? If you put x is equal to -1 in this first function, so within mod there is within mod -1, right? Again within mod there is, what is within mod -1, that is within mod -2, which is equivalent to 2. So which is equal to 2. And if you put x is equal to -1 here, you should get the same value 2, which is equal to within mod x is -1. So here we are putting x is equal to -1, so it is -1, which is equal to within mod -2, which is equal to, both are same, isn't it? That is within mod, if there is another mod, you have to write mod x -1. Okay, so only you have to write only one mod there. Okay, so this is the answer. So I think you have understood it, so you can copy it. Now let's do the next question now. So now we'll do the next question, that is 3 functions are given here. So let the function f such that r to r, that is real to real number, defined by f of x is equal to x square, and next second function g such that r to r, that is also real to real number, defined by g of x is equal to tan x, and the third function is h such that r to r, that is also real to real number, defined by h of x is equal to log of x. Okay, now you have to find out a formula for HOGO of GOF. HO within bracket GOF. HO within bracket GOF. You have to find out the formula for this HO within bracket GOF. Okay, and so you have to show that this within bracket HO within bracket GOF of root over pi by 4 is equal to 0. Is that clear? So now let us find out HOGO of HO within bracket GOF of x. Okay, so therefore you have to find out HOGOF of x. Let us find it. So now it is defined as, which is equal to, how will you write it? How will you write this one? H of within bracket, this is H within bracket, GOF is there, right? So within bracket you have to write GOF of X, bracket closed, which is defined as, which is equal to, again within bracket this GOF of X is defined as G of F of X, isn't it? That is H of G of F of X. First bracket, again this bracket is closed, again this bracket is closed. So I think you have understood it. Now let us put the value for F of X here. What is the value for F of X? It is X square. बुझ्दैछ होला तिमीले? यो F of X को सट्टामा हामी के लेख्छौं? X square लेख्छौं अब. Is equal to H of G of within bracket F of X here is X square. Is that clear? Now let us find out the value for G of X square. What is G of X there? Tan X. So instead of X here you have to put X square. So what is G of X square? It is tan X square, isn't it? That is, if G of X is equal to tan X, now you can get the value of G of X square. What is G of X square is equal to, this is your tan X square. Is that clear? So which is equal to H of within bracket, you have to write what is G of X square? It is tan X square. So I think you have understood it. So again you have to get the value for H of tan X square. So instead of X there is tan X square. So what is H of X here? Log of X. So H of X is equal to log X. So now instead of X what will you put? Tan X square. So H of tan X square is equal to, now instead of X you have to put tan X square. So it is log of, this is your tan X square. So I think you have understood it. So what is the value for H of tan X square? So instead of X you have to put tan X square. So its value will be log of tan X square. So this is the value for HO GOF of X. So I think you have understood it. So you can copy it. So now we'll do the second part. Now we have to get the value for HO GOF of root over pi by 4 is equal to 0. Right? So let us find it now. So just now we proved that HO GOF of X is equal to log of, it is log of within bracket tan X square. So now what will you put for X here? We have to put X is equal to root over pi by 4. So putting X is equal to root over pi by 4. So what do we get now? So therefore this becomes HO GOF of, what is X? Root over pi by 4, which is equal to, now instead of X you have to put root over pi by 4, which is equal to log of within bracket tan of, what is X whole square? That is root over pi by 4 whole square, isn't it? What is root over pi by 4 whole square? It will be pi by 4. It will be pi by 4, which is equal to log of, you know that tan pi by 4 is always 1. It is always 1. And what is log 1? It is defined as 0. So proved, which is equal to right hand side. So I think you have understood it. So you can copy it. Now we'll do the next question. So now let's do this question number 10. Let the function f such that a to b, and the second function g such that b to c, and the third function h such that c to d. These three functions are given. You have to prove that within bracket HOG bracket close OF is equal to HO within bracket GOF. You have to prove this LHS is equal to RHS. Okay. So now let us write down that let X belongs to the set A. Right. Let us write down left hand side. So therefore HOGOF, let us write it within bracket of X, which is equal to, it is defined as what? It is defined as HOG of f of X. It is just like your X, isn't it? That is HOG within bracket f of X. Now again it is just like your GOF of X, isn't it? Which is defined as G of f of X. Is that clear? So you can write here which is equal to H of G of f of X. H of within bracket G of f of X. This bracket is opened, this bracket is closed, again this bracket is closed. I think you have understood it. Okay. So which is equal to, now again it can be written as H within bracket. This is GOF of X, bracket closed. So which can be written as, now it can be written as HO within bracket GOF. Bracket is closed and then you can write X out here. So I think you have understood it. So from that is, this LHS is equal to this RHS, and from these two relation we can equate these two relation and we can cancel this X, so that we can write down that HOGOF is equal to HO within bracket GOF. So that is, which is equal to HOGOF is equal to HO within bracket GOF. So this is proved. I think you have understood it. So this is just like your associativity, isn't it? That is, this is known as associative property. That is, HOG within bracket OF is there is equal to HO within bracket GOF is there. Okay. So we have proved this LHS is equal to RHS. That is your proved. Okay. So now let's do the next question now. So now we'll do the next question, that is, if f be a greatest integer function, it is given that f be a greatest integer function. So you should know the meaning of greatest integer function, and g be an absolute value function. G is an absolute value function, means it is a modulus function. Absolute value function means it is a modulus function. G is a modulus function. You have to find out the value of fog of -3/2 plus gof of 4/3. So I think you have understood the question. Greatest integer function means that is f of X is equal to within third bracket X. Greatest integer function means X, that is its value within third bracket X is equal to greatest integer which is less than or equal to X. Within third bracket X means greatest integer which is less than or equal to X. This means that greatest integer which is less than or equal to X. F of X is equal to within third bracket X means this is the greatest integer function. So what is the meaning of greatest integer function? Which is equal to greatest integer which is less than or equal to X. That means if you put f of 1, so within third bracket 1, so this is the integer, you can put is equal to 1. You can write is equal to 1 because this is the greatest integer which is less than or equal to X. So 1 is equal to 1. 1 is the greatest integer which is equal to X. That is your 1. But if you write f of within bracket 1.8 which is equal to within third bracket 1.8. which is the greatest integer which is less than 1.8? That is your 1, isn't it? If you have f of within bracket 1 point, let us write 2.99, which is equal to, this means that within third bracket 2.99. So this means that which is the greatest integer which is less than 2.99? That is your, which is the greatest integer which is less than 2.99? That is your 2. Is that clear? Next, if you have f of within bracket minus 2.99, which is equal to within third bracket, what will you write by definition? Minus 2.99, third bracket close, which is equal to, which is the greatest integer which is less than minus 2.99? You have to write down the greatest integer which is less than minus 2.99. That is your minus 3. So I think you have understood it. If you have f of 5, which is equal to within third bracket 5, so this 5 is the greatest integer. That is greatest integer which is equal to x, means that is which is equal to 5, because it is integer itself. So within third bracket, if it is 5, you have to write is equal to 5. Okay, so I think you have understood this greatest integer function. Okay, next, what do you know? Absolute function. G is an absolute value function. You know that g of x is equal to within mod x. G of x is the absolute value function which is within modular sign x. The absolute value function means it is the modulus function. Is that clear? So now let us find out this one. Fog of within bracket minus 3 by 2. Okay, so therefore fog of within bracket minus 3 by 2, which is equal to, it is defined as f of within bracket g of minus 3 by 2, right? So which is equal to f of, what is g of minus 3 by 2? It is the modulus function. This modulus function g of minus 3 by 2 is equal to within mod minus 3 by 2, isn't it? So you can write here g of minus 3 by 2 is equal to, what is it? It is minus 3 by 2. Is that clear to all of you? So within bracket, what is g of minus 3 by 2? It is within mod minus 3 by 2. Is that clear now? So which is equal to f of, what is within mod minus 3 by 2? It is always positive quantity. So f of 3 by 2. Now you know that what is f of 3 by 2? It is the greatest integer function within third bracket. This is 3 by 2, which is equal to within third bracket, it will be 1 point something, isn't it? That is 3 लाई हामीले 2 ले डिवाइड गर्दा कति हुन्छ? 2 1s are 2, 3 minus 2 is 1.025s are 10, isn't it? Which is equal to 1.5. So which is the greatest integer which is less than 1.5? Which is equal to 1. So we have got this as 1. That is FOG, fog of within bracket minus 3 by 2 is equal to, what is the value? It is 1. So I think you have understood it. Okay. So now let us find out next. So you know the meaning of f as the greatest integer, that is f of x is equal to within third bracket x. Okay. And you know the meaning of g be an absolute value function, that is g of x is equal to within mod x, isn't it? So I am rubbing this one. So next you have to find out GOF. GOF, GOF of within bracket 4 by 3, which is defined as, how will you write it? G of f of 4 by 3, which is equal to g of, what is f of 4 by 3? This is the greatest integer function. That is, actually it was f of x is equal to within third bracket x, isn't it? What is f of 4 by 3? It is within third bracket 4 by 3. I think you have understood it. Within third bracket 4 by 3 is the greatest integer function which is less than 4 by 3, right? So now is equal to z within first bracket and within third bracket. What is 4 by 3? The 3 ले 4 लाई divide गर्ने 3 1 जा 3 1.0 3 1 जा 3 1.0 हामी यसलाई डेसिमल लेखौं so 3 3 जा 9 again 1 0 3 3 जा 9 again 1 0 3 3 जा 9 and so on 0.33 which never ends so it is 1.3333 etc right so which is equal to z so within third bracket 1.33333 means which is the greatest integer which is less than 1.333 that is your 1 right so it is z of 1 so you know that g is the absolute function absolute value function isn't it that is g of x is equal to within mod x you know that so g of 1 means within mod 1 which is equal to 1 so I think you have understood it so now since you have to get the value of this first term plus second term so let us write therefore it is fog within bracket minus 3 by 2 plus gof within bracket 4 by 3 which is equal to so what is the value of this function that is fog of minus 3 by 2 it is 1 plus what is the value for gof of 4 by 3 it is also 1 so 1 plus 1 is equal to what is the value that is equal to 2 so that is the final answer so I think you have understood it so now we'll do some theorems okay so we can copy it now we will do some theorems now so now we'll do this theorem number 1 the theorem number 1 is if the function f such that a to b and g such that b to c are both 1 functions then gof gof such that a to c is also 1 function you have to prove it you have to prove that gof that is composite function of f and g gof such that a to c is also 1 function so we have to prove it okay now in this case in order to prove 1 function for the function f we have to prove f of x1 is equal to f of x2 which implies that x1 is equal to x2 so we will use this method in order to prove this gof that is a to c is also 1 function okay now let us take two elements let x1 comma x2 that belong to the set A right so therefore let us take this gof x1 is equal to gof x2 so in order to prove that this gof such that a to c is also 1 function you have to prove that from this relation you have to prove that x1 is equal to x2 is that clear now so which implies that in this case gof of x1 means it is defined as z of f of x1 which is equal to gof of x2 is defined as z of f of x2 so I think you have understood it now this is just like your g of x1 g of x2 isn't it तो यो f of x1 लाई हामीले x1 ले रिप्लेस गर्यौं यो f of x2 लाई x2 ले रिप्लेस गर्दा के हुँदैछ यो g of x1 is equal to g of x2 हुँदैछ के हुँदैछ हैन that is g of x1 is equal to g of x2 हुँदैछ त यहाँ हामीलाई के दिएको छ g is also a 1 function since g is also a 1 function it implies that x1 is equal to x2 is that clear so similarly instead of x1 there is f of x1 and instead of x2 there is f of x2 so which implies that since g is 1 function we can write x1 is equal to x2 so in this case we can write f of x1 is equal to f of x2 so what is the reason behind it since g is what 1 1 since g is 1 1. So we can write f of x1 is equal to f of x2. Again, since f function is 1 1 function, we can write down that x1 is equal to x2 since f is also 1 1. Since f is 1 1. Is that clear now? So GOF of x1 is equal to GOF of x2. What does it imply? x1 is equal to x2. That means GOF is also 1 1 function. So hence GOF such that A to C is also what? 1 1 function. Is also 1 1 function. So it is proved. So I think you have understood it. So this is the mathematical problem of 1 1 function. Okay. So now we'll do the next theorem. In the next theorem, we have to prove that if f and g are both onto function, then GOF A to C is also onto function. We will prove that. We will prove that theorem now. Okay. So you can copy it. So now we'll do the next theorem, that is theorem number 2. If the function f such that a to b and the function g such that b to c are both onto functions. So both these functions f and g are onto functions. Then GOF such that a to c is also onto function. You have to prove that this GOF from a to c is also an onto function. So I think you know the meaning of onto function. I told you about onto function. The function f such that a to b is said to be an onto function if each element in the set B has at least one preimage in the set A. That is known as onto function. Okay. So if y belongs to the set B, for onto function you have to prove that if y belongs to the set B, then there exists x belongs to the set A such that f of x is equal to y. Is that clear? This is how to prove the onto function. Okay. So this is the definition of onto function. So the function f such that a to b is said to be an onto function if each element in the set B has at least one preimage in the set A. This is onto function. That is, if y belongs to the set B, there exists x belongs to the set A such that f of x is equal to y. So I think you have understood it. Okay. So let us prove this theorem now. So in this case, you have to prove that GOF such that a to c is also onto function if both these functions f and g are onto function. Okay. So you can draw the diagram also here. Suppose this is set A, this is set B, and this is set C. Right. This is your A, this is your B, and this is your C, set C. Okay. Now this is your F, this is your what? Z. And this is your GOF, isn't it? This is your GOF. Right? So now, suppose Z belongs to the set C. Suppose Z belongs to C. Then there exists Y. Then there exists Y that belongs to the set B such that Z of Y is equal to Z. Such that g of y is equal to z. Okay. Let z belongs to the set C. Then there exists an element y belongs to the set B such that g of y is equal to z because z is onto function. Because z is what? Onto function. Right. You can write g of y is equal to z. Is that clear? Again, since f is onto function, since f is onto function, if y belongs to the set B, then there exists x belongs to the set A such that f of x is equal to y, because in this case f is also onto function. So I think you have understood it. So f of x is equal to y and g of y is equal to z. I think you have understood it. Okay, so we will write down here now. So this is just you just try to understand it. Okay, that is z belongs to the set C. Since g is onto function, so there exists y belongs to the set B such that g of y is equal to z. Is that clear? Next, since f is onto function and y belongs to the set B, there exists x belongs to the set A such that f of x is equal to y. So this is the definition of onto function. Okay, so we will write down here now. So let us prove it now. Proof. So now let z belongs to the set C. Then you know the meaning of this one. Then there exist. This is the symbol of there exist, mathematical symbol of there exist. Then there exist y belongs to the set B such that this g of y is equal to z. Since z is onto function, okay, so since z is onto function, you can write g of y is equal to z. Is that clear? Again y belongs to the set B, then there exists what? X belongs to the set A. X belongs to the set A such that f of x is equal to y. Here also f is onto function. Since f is onto function. So I think you have understood it. Okay, so now you can write therefore. Now you have to prove that gof is also onto function, so you can write gof of x. So write down gof of x is equal to, it is defined as, it is g of f of x is equal to g of, what is f of x? F of x is equal to y, because g is onto function, so you can write f of x is equal to y. Again g is onto function, so we can write gy is equal to z. So gy is equal to z. Okay, that means gof of x is equal to z. So here we have written that, since let z belongs to the set C, there exists y belongs to the set B such that g of y is equal to z. Since g is onto function, you can write g of y is equal to z. Here also y belongs to the set B, then there exists x belongs to the set A such that f of x is equal to y. We can write down this one because f is onto function. So f is onto function, that's why we are writing f of x is equal to y. So here also, since we have proved that gof of x is equal to z, so therefore gof is onto function. तो यहाँ के बाद gof is onto function. बुझे ना? So g of y is equal to z, समझे g is onto function. F of x is equal to y, समझे f is onto function. Gof of x is equal to z, समझे तो z को pre image automatically के मा आउँछ gof मा आइहाल्छ. यो z को pre image के मा आउँछ gof मा आउँछ. That is यो z को pre image चाहिँ x छ, which includes in the gof. That means gof is also onto function. So hence gof such that A to C is onto function. So I think you have understood it. This Z belongs to the set C. So there exists x belongs to the set A directly. There exists x belongs to the set A under GOF. Okay, so here GOF is onto function. Is that clear? Since Z belongs to the set C, isn't it? This Z belongs to the set C. So this Z belongs to the set C. There exists x belongs to the set A under the function GOF. So in this case, GOF such that A to C is onto function. So it is proved. So I think you have understood it. So you can copy it. So now this much is for today. So आज हामीले जति पनि प्रब्लम्सहरु गर्यौं, अच्छा म तिमीलाई होमवर्क दिइहाल्छु पहिला ल. पहिला यो कपी गर, देन आई विल गिभ यु द होमवर्क. त यहाँ कतिवटा मैले यो बुकमा जुन चाहिँ एक्सरसाइज छ, त्यो कतिवटा एक्सरसाइजको प्रब्लम यहाँ गरेको छैन, त्यो चाहिँ तिमीले घरमा गर्नुपर्छ. ठीक छ? त यो कपी गर्नु. नाउ आई विल गिभ यु सम होमवर्क from the book, that is Senior Secondary School Mathematics for class 12. Okay, so you can copy it. So now these are your homework. So question number 2, it is same as question number 1. Okay, so question number 2 is let f such that this is the set A to set B. Here set A is given as 3, 9, 12, 2, 1, 3, 4, and G such that this is set B to set C, or it may be from set C to set D. Okay, G such that 1, 3, 4, 5 to 3, 9. So these are the two functions given, and it is defined as f is equal to within second bracket 3 is related with 1, 3 is related with 1, that is 3, 1, 9, 3, 12, 4, and G is equal to within second bracket 1, 3, 3, 3, 4, 9, 5, 9, bracket close, second bracket close. These are the set of ordered pairs. Okay, you have to find out number 1 GOF and number 2 fog. So this is same as question number 1. You can do it. Okay, so this question number 4 is same as question number 5, right? This question number 4 is same as question number 5 and question number 3, right? So let f such that real to real number, R to R means real to real number, such that f of x is equal to 2x plus 1. f of x is equal to 2x plus 1 अनि g function दिएको छ, such that real to real number again. It is defined as g of x is equal to x square minus 2. So you have to write down the formula for number 1 GOF. You have to find out GOF of x. Number 2 fog, that is fog of x. Number 3 FOF, that is FOF of x. And number 3 GOG, that is GOG of x. Okay, so I think you can do it. This question number 4 is similar to question number 3 and question number 5, and this question number 2 is same as question number 1. Okay, so I think you have understood it. So I think you have understood all the problems that we did today. त तिमीले घरमा राम्रोसँग रिभिजन गर्नु. यो जति पनि नोटेसन्सहरु छ, यो गफ फक केहरु छ, यो तिमीले नोटेसनहरु राम्रोसँग याद गर्यौ र यसलाई प्र्याक्टिस गर्यौ भने चाहिँ you can do very well in this composition of functions as well as in case of functions. Okay, त तिमीले घरमा चाहिँ यो रिभिजन गर्नै पर्छ अनि यो दुईटा होमवर्क पनि गर्नु. ठीक छ? So in the next class we will do invertible functions. We will do invertible functions in the next class. Okay, so this much is for today.